Good morning, students. This is Latif sir. This is your first online class of this session, and today I am going to start the first chapter of class 11th chemistry. The topic is some basic concept of chemistry. In this chapter, basically those topics are included which you have already studied in class 9 and 10. For example, mole concept you have already studied in class 10, and empirical formula, molecular formula calculation you have already studied in class 10th, and units of different physical quantity, what is matter, what is matter, and what is element, mixture, compound. All these points, all these topics are given in this chapter, but these topics are not important for class 11. That is what is matter. You know that you have already studied about these points, these topics in lower classes. Okay, so these are not important. What is matter, what is element, what is a compound, what is a mixture, okay, and different state of matter, that is solid, liquid, gases. These points are given. You have to read, but just read thoroughly. These are not important point for class 11. Okay, and in this chapter units of different physical quantities also given, and what is significant figure, what is the relation between different scale of temperature. All these points are given, but these are not important for class 11. However, there are few new topics are also given. For example, laws of chemical combination, equivalent weight, and their calculation of equivalent weight. These are new topic, and concentration calculation. Okay, so I will discuss only those points which are important for class 11. Okay, so let's start. Today first I will discuss about laws of chemical combination. Laws of chemical combination. So what are these law? The combination of elements to form compounds is governed by some basic law, and these laws are known as laws of chemical combination. The combination of elements to form compound is governed by some basic laws, and these basic laws are known as laws of chemical combination, and these laws are law of conservation of mass, law of definite proportion, law of multiple proportion, law of gaseous volume, that is Gay-Lussac law, and you have already studied in class 10 about Gay-Lussac law and Avogadro's law. So first law is law of conservation of mass. Law of conservation of mass. This law was stabilized by a French chemist, Antoine Lavoisier. And according to the law of conservation of mass, in all physical and chemical changes, the total mass of reactant is always equal to that of the product. That is, mass of reactant in a chemical reaction, mass of reactant will be equal to mass of product. This is a statement of law of conservation of mass. In other words, you can say matter can neither be created nor destroyed. Okay. For example, when ice melts on heating, ice melts, start melting, and it will convert into water. So in this physical change, it is found that there is no change in weight, though a physical change has taken place. Mass of ice will be equal to mass of water. Okay. And when matter undergoes a chemical change, for example decomposition of mercuric oxide, then in all type of the chemical reaction, you will see that mass of reactant will be equal to the mass of product. Okay, here Hg mercuric oxide is heated and it forms mercury liquid, Hg liquid and half O2. So total mass of mercuric oxide will be equal to total mass of mercury plus oxygen. Okay, now see second law of second law of chemical combination, law of definite proportion. Law of definite proportion, important law. These laws are important, you have to remember. Okay, so law of definite proportion, according to this law, a pure chemical compounds always consist of the same element combined together in fixed proportion by weight. Law of definite proportion, according to this law, a pure chemical compound always consists of same element combined together in a fixed proportion by weight. For example, carbon dioxide, it may be formed in a number of ways. Carbon dioxide may be formed by burning coke in air, that is C plus O2 implies CO2. Or you can also prepare carbon dioxide by decomposition of limestone, CaCO3 on heating. CaCO3 arrow on heating CaCO3, it gives calcium oxide and carbon dioxide. Okay, and similarly you can also you can prepare carbon dioxide by the reaction of sodium carbonate and HCl. By the reaction between sodium carbonate Na2CO3 and hydrochloric acid, you will get sodium chloride, water and carbon dioxide. So you can prepare carbon dioxide in many ways. Okay, but in this all method of preparation of carbon dioxide, you can see in all these three samples of carbon dioxide, carbon and oxygen are in the ratio of 3:8. That is means in all cases the mass of carbon is 12, carbon is to oxygen. The mass ratio in all cases, in all these three cases, you will get carbon dioxide, and the ratio and the mass ratio between carbon and oxygen in all these three cases will be carbon is 12 CO2 and oxygen is O2 means 16 into 2, that means 32. So the ratio will be 3 is to 8. 3 is to 8. Okay, that's why it is written a pure chemical compound always consists of same element in all cases. In all these three methods of preparation of carbon dioxide is formed by combination of carbon and oxygen, and the formula is CO2 always. Okay, so a pure chemical compound always consists of the same element combined together in a fixed proportion by weight. That means the ratio will be always, the mass ratio or weight ratio will be always equal. Second, law of multiple proportion. Law of multiple proportion. According to this law, if two elements combine to form two or more compounds, if two elements combine to form two or more compounds, the weight of one of the elements which combines with the fixed weight of the other in these compounds are bears a simple whole number ratio by weight. According to law of multiple proportion, if two elements combine to form two or more compounds, the weight of one of the element which combine with the fixed weight of the other in these compounds bear simple whole number ratio by weight. For example, when hydrogen and oxygen combine, it will form water or hydrogen peroxide. Okay, so When 2 gram of hydrogen combine with 16 gram oxygen, you will get 18 gram water. Similarly, if 2 gram hydrogen combine with 32 gram oxygen, you will get 34 gram hydrogen peroxide. Okay, the initial reactants are same, but the products are different. In one cases it is water, and in other case it is hydrogen peroxide. Here the masses of oxygen, that is 16 gram and 32 gram, which combine with a fixed mass, that is 2 gram of hydrogen. Okay, here the masses of oxygen, that is 16 gram and 32 gram, which combine with a fixed mass of hydrogen, that is 2 gram, bear a simple ratio which is 16 is to 32. 16 is to 32 means 1 is to 2. This is a simple ratio. Next, Gay-Lussac law of volume, gaseous volume. The law states that under similar condition of temperature and pressure, whenever gases combine, they do so in volume which bear simple whole number ratio with each other and also with the gaseous product. And the law may be illustrated by the following example. For example, combination of hydrogen and chlorine. When hydrogen and chlorine combine, you will get hydrogen chloride, HCl, H2 plus Cl2 arrow 2HCl. So in this reaction, one volume hydrogen combine with one volume chlorine to form two volume HCl. So the ratio in the volume of reactant and product is 1 is to 2, 1 is to 1 is to 1, 1 is to 1 is to 2. This is a simple ratio. Okay, and similarly, combination between nitrogen and hydrogen, the two gases lead to the formation of ammonia gas under suitable condition. The chemical equation is N2 plus 3H2 arrow 2NH3. So one volume of nitrogen combined with 3 volume of hydrogen to form 2 volume ammonia. So the ratio is volume ratio between among the reactant and product is 1 is to 3 is to 2. This is a simple ratio. Okay. So according to Gay-Lussac law of gaseous volume, under similar conditions of temperature and pressure, whenever gases combine, this law is applicable for gaseous reaction. Okay, remember that Gay-Lussac law. So according to this law, when gases combine, they do so in volume which bear simple whole number ratio with each other and also with gaseous product. Okay, and last law is Avogadro's law. Avogadro's law. Avogadro's proposed that equal volume of all gases at same temperature and pressure should contain equal number of molecules. According to Avogadro's law, equal volume of all gases at same temperature pressure contain equal number of molecules. Very simple law. Okay. Suppose here one volume of hydrogen, one volume of oxygen, uh, one volume of hydrogen combined with one volume of hydrogen with one volume of oxygen, it will form two volume of water vapor. If we consider the reaction of hydrogen and oxygen to produce water, we see that two volume of hydrogen combine with one volume of oxygen to give two volume of water without leaving any unreacted oxygen. That means equal volumes, according to Avogadro's law, you can say equal volume of gases at same temperature and pressure should contain equal number of molecules. Okay, thank you students. Again next day I'll discuss about some new topic from this chapter. Bye students.